Hi there! In this video, we are going to be learning how to create equations with no solutions or infinitely many solutions. A solution is a variable that makes an equation true. In many equations that you have seen before, there is one solution. For example, given the equation 12 equals 2x plus 4, when you solve for x, you get your one solution to be x equals 4. Sometimes, however, there is more than one solution to your equation, more than two. In fact, there are infinitely many solutions. Let's take a look at this equation. 4 times, in parentheses, x plus 4, close parentheses, equals 4x plus 16. To solve this, first, we distribute on the left-hand side, which gives us 4x plus 16 equals 4x plus 16. Then, we subtract 16 from both sides. Next, we can divide both sides by 4. This gives us x equals x. That's a little weird. What does it mean? Well, since x equals x is always true, any number is a solution to this equation. Let's try it. Let's see what happens when x equals 1. When you plug in 1 for x, you get 4 times the quantity 1 plus 4 equals 4 times 1 plus 16. When I add what's in my parentheses, I get 4 times 5 equals 4 plus 16. On the left-hand side, when I multiply 4 times 5, I get 20. And on the right-hand side, when I add 4 plus 16, I also get 20. This means I now have 20 equals 20. Since this is a true statement, I know that 1 is a solution to my equation. Now let's try x equals 0. When you plug in 0 for x, you get 4 times the quantity 0 plus 4 equals 4 times 0 plus 16. When you simplify on the left-hand side, you get 4 times 4, which equals 16. And when you simplify on the right-hand side, you get 0 plus 16, which also equals 16. 16 equals 16 is a true statement. So 0 is also a solution to this equation. We could keep going. In fact, this equation has infinitely many solutions, since any value of x makes it true. For an equation to have infinitely many solutions, like in this example, your variable term and your constant terms must both match when you distribute both sides of your equation. Remember that your variable term is the term with x in it, and your constant term is the number not attached to a variable. In our first example, we are asked to find the missing number so that the equation has infinitely many solutions. The equation reads 3x plus 4 equals 3x plus blank. Right away, when I see the terms infinitely many solutions, I know I am looking for two identical expressions on either side of my equation. Since I know these two terms must match, I can plug in 4 as my missing constant on the right-hand side. At this point, our equation reads 3x plus 4 equals 3x plus 4. I know, since these two expressions are identical, that this equation has infinitely many solutions. If I wanted to check my answer, I could start by subtracting 3x from both sides. When I subtract 3x from both sides, I am left with the true statement that 4 equals 4. Since this statement is true, I know I have solved this equation correctly and that the missing constant is 4. For this example, we are again asked to find the missing number so that our equation has infinitely many solutions. This means we are looking for identical variable terms and constant terms on each side of our equation. To start, we can distribute our negative 3 on the left-hand side of our equation by multiplying negative 3 by each term inside of our parentheses. Once we do this multiplication, we get negative 3x plus 12 equals blank x plus 12. At this point, we can see that our constant terms are already identical as 12. To make our variable terms match, we simply add in a negative 3 on the right-hand side so that our equation reads negative 3x plus 12 equals negative 3x plus 12. I know this equation will have infinitely many solutions because our constant terms and our variable terms both match. While some equations have one solution and others have infinitely many solutions, there are still some equations that have no solutions. Let's take a look. This equation reads 3x plus 5 equals 3x plus 7. Let's try simplifying it. If we subtract 3x from both sides of the equation, we get 5 equals 7. But 5 does not equal 7. That means there are no numbers that I can plug into this equation to make it true. Let's try it. If I were to plug in 2 for x, our equation now reads 3 times 2 plus 5 equals 3 times 2 plus 7. When we multiply, we are left with 6 plus 5 equaling 6 plus 7. Now we are left with the statement 11 equals 13. But that's not true. This means that there are no solutions to this equation. Since there are no numbers for x that make this equation true, we say this equation has no solutions. For an equation to have no solutions, it must have the same variable term on both sides of the equation, but have different constant terms. When this occurs, no matter what number you plug in for the variable, the equation will never read true. In this question, we are being asked to identify the number that will make the equation have no solutions. The equation given is 5x minus 7 equals blank times x minus 8. Right away, when I see the words no solution, I know that I am looking for two expressions with matching variable terms but differing constants. Notice right away that our constants are already differing. On the left-hand side, we have negative 7, and on the right-hand side, we have negative 8. To make our variables match, we can look on the left-hand side to see that we have 5x, so our missing number on the right-hand side must also be 5. When we plug in that 5, we are left with the equation 5x minus 7 equals 5x minus 8. At this point, we could plug in any value for x and our equation should read not true or false. I hope you found this video helpful and feel better creating equations with no solutions or infinitely many solutions.